This is the second half of section 1.8. Yesterday you did transformations involving translations and reflections, and today you're going to do transformations involving stretches and compressions. So just a reminder that transformation is a change in the size, shape, or position of a figure. And today we're going to talk about a stretch. Now a stretch is going to pull a figure along the x-axis, and if that happens, it's going to be a horizontal stretch. So kind of think of it like this. It's pulling it along the x-axis. That's a horizontal stretch. Or it's going to pull it along the y-axis. So again, think of your coordinate plane. If I'm pulling this way, it's going to be a vertical stretch. When you are performing a stretch, you multiply by a number greater than 1. Yesterday you added or subtracted to do translations, but when you do stretches or compressions, you multiply. If it's a stretch, you multiply by a number greater than 1. If you multiply 1, the figure is by 1, the figure won't change at all. Just like when you multiply a number by 1, the figure is not going to change. Okay, compression. A compression is a transformation that pushes a figure along the x-axis. And if that happens, so compression, think of your coordinate plane again. Let's see if I can get my hands in here. You're pushing it along the x-axis, so that's going to be a compression. And that's horizontally. Or you can go the other way on the y-axis, and if you look at, think of putting your hands on the y-axis and just bringing them together, that's going to be a vertical compression. When you're performing a compression, you multiply it by a number between 0 and 1. Notice I didn't say a number less than 1, because think of if we would multiply by a negative 2, that's less than 0. We say between 0 and 1. We don't say less than 1, because if we think of negative 2 is less than 1. But the problem is that the negative in transformation represents a reflection. So if we take that negative off because it represents a reflection, the 2 is actually going to be a stretch. So again, we need to say between 0 and 1. Okay, if we look at vertical stretches or compressions, this is with points, the operation we do is to multiply. So if A is greater than 1, and again, A is the number the point is multiplied by, then you have a vertical stretch. And again, each point is pulled. Another way you can think about it, a vertical stretch, when you're stretching vertically, you're going this way. So think of where the x-axis is. You're pulling it away from the x-axis. If A is less than 1, absolute value of A, I should be saying, is less than 1, you have a vertical compression. So it's going to push your points. Vertical compression goes like this, so it's going towards the x-axis. So this is how you show a stretch or a compression. The original point is 1, 5. If I take the x stays the same and the y gets multiplied, I just chose the number 3. We're going to multiply 5 by 3, so that would give us 15. Now horizontal stretch or compression, same thing. You're going to multiply. If the absolute value of B, and B is the number that you're multiplying the point by, is greater than 1, then you have a horizontal stretch. And each point is pulled away from the y-axis. So again, think of a coordinate plane. I'm taking my hands here. I'm pulling it. So a horizontal stretch, it's going away from the y-axis. Along the x, away from the y. It's a horizontal stretch, and each point is pulled away from the y-axis. So if B is less than 1, you have a horizontal compression, and each point is pushed toward the y-axis. So again, think of just taking your hands along the coordinate plane. If I'm pressing in along the x-axis, I'm going towards the y-axis also. So here we're taking the point 1, 5, and we're multiplying the x-coordinate by 3, and we'll have the point 3, 5. When you graph transformations of functions, use a table of x and y values. You're going to include a column for the transformation. if the transformation affects the x-coordinate, add the transformation column on the left side. It affects the y-coordinate, add the transformation column on the right side. Choose enough points on the function to give you the shape of the graph, and always graph what I call critical points. Those are points that give where the direction of the function changes. I'm talking about curves, angles, and your final direction, and that's in quotes, and I'll explain that a little bit on the next page when we actually go ahead and do that. So if we want to horizontally compress the function by a factor of 1/2 in graph, we're going to multiply, and the x-coordinate, because it says horizontally, remember horizontal affects the x-coordinate, we need to look at the graph, and what we're going to do, I just made it darker here, what we're going to do is pick up the critical points. Well, where are the critical points? The critical points are any angles, so here's where a change in direction. And then we need a final direction. And this goes on forever, but I can pick any point this way. I'm just going to pick one here and here. And that's enough to give me the shape of the graph. If I had only picked these 2 points, I would probably just draw a straight line. So pick enough points to give you the shape of the graph. Then what you're going to do is you're going to transfer those points into a table. And I'm going to cover up this column first right now. I just wrote all the points, the x and the y, in the table, and we know we want to horizontally compress by a factor of 1/2, so that means I'm going to multiply all of the x-coordinates by 1/2. And when I do that, this x is going to change to -2, this is going to change to -1, this is going to change to 1/2, and that will be 3/2. Now what I'm going to do, I am going to scribble out this column because I don't want to make the mistake of graphing 2 x's here. That would give me the wrong shape. So if I cross this off, that's the one, that's the old x-coordinate. Now we have a new x-coordinate, but we haven't done anything with the y-coordinate, so that one stays the same. Now we graph this point, -2, 4. So we're going to go to -2, 4, and then -1/2, 1, +1/2, 1, and 3/2, -3. And then you're just going to connect those points, and I'm just going to graph it in a different color so you can hopefully see the change. Keep in mind what our original goal was here. We wanted to apply a transformation that would horizontally compress the graph by a factor of 1/2. Okay, so compress. Look at the black function that I have here. Now I'm compressing it horizontally, so I'm bringing, think of what's happening to the black function. I'm pressing it or compressing it horizontally, so it's squishing this way. So it does look like it got smaller here, and this pushed up over here, this pushed here. So that's your horizontal compression. All right, you have a couple of things to try.